Glass manufacturing process. What is glass made of? The marvels of glass all stem from liquefied sand. In the present day, glass has become so prevalent that looking through it has become second nature. It adorns windows, screens, cabinets, and countless daily devices. Despite its omnipresence, one could go a lifetime without delving into its manufacturing process or its constituents. Even those familiar with the fundamentals have merely skimmed the surface. At its core, glass is sand, subjected to intense heat and chemical transformation. If you've ever walked along a beach, you'll understand the scorching temperature sand can reach while still solid. The heat required to melt sand into a liquid state, ultimately forming glass, surpasses even the hottest of sunny days. Melting sand demands temperatures of around 1700 degrees, 3090 degrees, akin to those experienced by a spacecraft re-entering Earth's atmosphere. Sand used in glass making typically comprises minute grains of quartz crystal born from silicon dioxide molecules, also known as silica. When heated sufficiently, these molecules cause the sand to melt, shedding its crystalline structure. Upon cooling, it adopts an entirely new molecular arrangement, residing in a state between liquid and solid. This intermediary state is termed an amorphous solid, blending some solid crystalline structure with the random molecular nature of a liquid. The properties of glass can vary depending on the sand blend. Introducing certain elements or chemicals to the mix can alter the glass's color. Furthermore, the production method and subsequent shaping processes can influence glass properties. To bolster glass durability, manufacturers may employ annealing techniques, rapidly heating and cooling the glass. Additionally, glass can undergo chemical reinforcement through ion exchange processes, fortifying its surface. The most familiar form of glass for many is soda-lime glass, crafted from a blend of soda, also known as soda ash or washing soda, lime, and sand. While basic glass can be produced by heating and rapidly cooling silica, the creation of soda-lime glass is slightly more intricate. The addition of soda, sodium carbonate, reduces the sand's melting point, enabling glass formation at lower temperatures and conserving energy during manufacturing. However, soda incorporation diminishes its chemical resilience, rendering it more susceptible to dissolution upon contact with liquids. To counteract this, lime, calcium carbonate, is introduced to the mix, serving as a stabilizer. Once the silica, soda, and lime mixture is heated, it can be cooled and shaped for various applications. At Corning, glass is our domain. We specialize in enhancing it through chemical processes like ion exchange, and we excel in shaping it to produce optical fibers that span vast distances. With over a century of experience, our understanding of glass keeps us at the forefront of research and development. From simple soda-lime compositions to intricate glass structures for practical enhancements, glass proves to be an adaptable material. That's why, after 165 years, we're still uncovering new breakthroughs. Glass sand accounts for about 3/4 of the glass composition. Floating glass. The float glass is somewhat like a river of molten glass flowing out of the furnace before the cooling process. It stretches to nearly 300 meters long, then is cut into large sheets. These sheets typically have dimensions of 3.21 to 2.25 meters. Thus, the float line has the capability to continuously produce glass throughout day and night. Floating glass is a glass sheet produced by the float process, where molten glass floats on a molten metal surface, typically tin. It relies on the principle of buoyancy, as the liquid glass has a density of 1.40–1.42 g cm3, lighter than the liquid tin at 5.85 g cm3. Lead and other metals were previously used, but not as efficiently as tin. This method results in glass sheets of even thickness and very flat surfaces. Tin is a low-cost metal, suitable for the float glass process because it has high density, adhesion, and inseparability with molten glass. Tin, however, oxidizes in natural air to form tin dioxide, SNO2. Known in the manufacturing process as tin seeding, tin dioxide adheres to the glass. To prevent oxidation, the tin bath is provided with a protective gas mixture of nitrogen and hydrogen at positive pressure. The float glass manufacturing process can be divided into 5 common steps. 1. Raw material. Batch. The glass manufacturing raw materials include silica, sand, a non-metallic substance with the chemical formula SiO2, found abundantly in nature and exists in the form of quartz sand or quartz powder. Dolomite rock, a sedimentary rock carbonate and a mineral. Soda, sodium carbonate. Lime rock, sulfate salts, some other additives as colorants, refining agents, or to adjust the physical and chemical properties of the glass. The main components, including silica sand, calcium oxide, soda, and magnesia, are weighed and batched to be added to the recycled glass. Cullet. Using cullet reduces energy consumption. Materials are checked and stored for mixing later under computer control. The superior transparency provided by Saint-Gobain clear glass is the result of the purity of the raw materials, the accuracy of the composition, and strict adherence to high-quality standards in the manufacturing process. The company has a dedicated sand processing plant in Tata, where silica sand used in production is refined and excess iron content is removed from the material. 2. Melting the raw material. In furnace. The raw material and the cullet are fed into the glass melting furnace. Raw materials by batch transferred from mixing silos to 5 melting furnaces where they melt. The temperature in the furnace rises to 1600 dE gross. The glass after exiting has a temperature of about 1200 dEs. To make sure the glass is of the correct size, the glass furnace's structure is 9 mm wide, 45 mm long, and can hold about 1200 tons of glass. 3. Floating glass. Drawing on tin bath. The molten glass is then floated onto the molten tin bath at around 1000 degrees C. The glass flows on the surface of the molten tin to form a long, smooth glass ribbon on both sides. It forms a ribbon, typically sized from 5 to 6 mm. By pulling the glass appropriately through a complex process involving the rolling machine on top, ribbon thickness can be achieved from 1.9 mm to 19 mm. The glass sheet is lifted from the tin bath onto rollers at a controlled speed. The thickness and size of the glass sheet are determined by an ancillary device called the edge draw machine, located on both sides of the tin bath. The glass has high viscosity, and the tin is very liquid. They do not mix, and the contact surface between the two materials is completely flat, giving rise to the term flat glass for the final product. 4. Cooling the molten glass. During annealing, as it leaves the molten tin bath, it is gradually cooled to prevent stress and cracking. The glass, now at a temperature of 600 degrees C, is sufficiently cooled to enter a chamber called a layer. The glass is now hard enough to pass through rollers and is annealed, helping to adjust internal stresses, allowing for cutting and processing of the glass in a predictable manner and ensuring flatness. Since both surfaces are fire finished, they do not require grinding or polishing. 5. Quality, inspection, cutting, and automated storage. After cooling, the glass undergoes rigorous quality inspection. It is then cut into various sized sheets, with a maximum size of 6000 mm x 3660 mm. Subsequently, it is automatically stacked, stored, and ready for transportation. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.